Everybody find a seat. So I'm Nash Foster. I'm the CEO of Pyrofex. I think I've met most of you, but if I haven't, howdy. Thanks for coming. This is an incredible crowd. I didn't expect us to fill this room today, but there you all are. So we don't have slides for this presentation. Our goal is basically going to be to review the project, sort of set the stage for the next couple of days, just give you guys a sense of the pieces of what we've been doing over the last year, how they've been coming along, what we're going to accomplish over the course of the coming year or so, and what you can expect from Mercury. This is Mike Stay. He's the CTO of Pyrofex. He's the dev lead. He's the big guy. So we'll be going back and forth, just talking about individual components, of the project and that kind of stuff. So I just want to take a few minutes. Look around. There's 150, 160 folks here today, which means we've come a long way since just November when we had our first dev retreat in Park City, Utah. There were 23 people. So we've expanded a lot. There's a lot of interest has developed and grown, and that couldn't have happened without you guys. So take a second, look around. Thank you all for being here. Thank you all for taking the time and energy to invest in Rchain and to believe in what we're doing and the possibilities of this project. Over the course of the next 2 days, you're going to hear a lot of talks from people on the dev team, from people in the Rchain community on a variety of different topics. Hopefully everybody got a schedule and you can choose what you're interested in. I want to in particular call out that there's a number of talks from folks at Pythia and Reflective Ventures, who are the Rchain community's venture firms, right? Those talks are going to be very interesting on a lot of information on the business side of how we're going about building the ecosystem in general that's going to facilitate the deployment and adoption of Rchain, right? So today for this talk, Mike and I are going to focus on the platform itself and how that development effort's coming. But throughout the course of the next 2 days, you're going to get a lot of information about a lot of different stuff. You should take full advantage of all of that. Okay, so we'll start with sort of logistical stuff. When Greg came to Mike and I about this time last year and said, I need your help developing this platform, it was essentially the three of us, right? Greg and Mike and Nash, and we didn't have hardly anybody else. We went out almost immediately and hired Tim, who's hiding in the back over there, and a couple of other guys who are no longer with us. But in the summer of 2017, we were still, I think, about 5 people plus Kent part-time and Joe part-time, and it was a very small team. At this point, we've grown to over 20 devs, almost all of whom are full-time at this point. Hiring is continuing to go well. This month, we're going to hire 6 more developers on the Rchain team. Thank you. Our target for sort of stabilization is around 30, 35 total full-time developers. That number gets approximately a full 4 to 5 man team on all the major components that we're about to talk about, and it will allow us to, get the Mercury release out and then get through Venus and Earth and stabilize into the future. And at that point, who knows what will happen, but that's sort of where we are on the hiring front. As far as the development effort goes, so we've got what looks like there's 7 different components of the dev project that we consider important. And so I'm going to list them off, and then I'm going to sort of turn each one over to Mike and let him talk about the exact status of each one. But at a high level, the various components are the RSpace storage engine, Rolang, the Roscala VM, the Rosette C++ VM, the communications layer, consensus, and contracts of various different kinds. Right, so those are the components of the architecture that you'll be hearing about over the course of the next 2 days. There's at least one talk on each of those 7 different things. So take a look in your program, try to find the ones that you're most interested in as you hear us go through how they're going. Then at the end of this talk, we're going to spend a little bit of time talking about infrastructure projects and some of the details of what's got to go on there. A couple of talks this week that are related to that. And then one of the topics that keeps coming up that we are also going to address briefly here, we want to hear from all of you guys over the course of the week, is documentation how to get knowledge into people's hands, how to educate people on Rchain, how to develop for the platform and all that kind of stuff. So that's what we're going to cover here today. Sorry, so with that said, Mike, why don't you tell us about how things are going with storage?
Great. Before getting into the details of this, we have a really broad audience here, and so I wanted to speak more about the overarching architecture. Rchain itself is one of many different blockchains that intends to run smart contracts. So Bitcoin came out. It was a wonderful thing, this unexpected ability to establish consensus among a group of machines that don't trust each other. They have no reason to believe anything that the other one says. That's the first major development in consensus since the ziggurat, right? Before that, you had to have people trusting each other to some extent in order to achieve this agreement on what the state of something was. Now, Bitcoin gets consensus on the state of a ledger, so how much money is in everyone's wallet. But once they knew that was possible, Ethereum came along and said, well, let's get consensus on the state of a computer. And this computer can run any program you want. It's merely a matter of writing it. Now, many of the interesting programs that you write are about money. You can certainly write a ledger program, but you can also write derivatives and that sort of thing. If you look at the derivatives market, we're somewhere around $800 trillion a year in derivatives market. The US GDP is a fraction of that.
20 trillion.
So if we can capture any portion of that, it's going to make everybody very happy. Ethereum has some problems. These are things that we're trying to address in the Rchain platform. The 7 components here: storage. We need some way of maintaining the state of the system. We have to record what everybody's agreeing on. We also need to be able to roll back speculative execution as we learn more about what different parts of the network have come to agreement on that we haven't learned about yet. So pushing forward in different directions, but eventually we all come to the same answer. Rchain is the language itself. How are we going to program this computer? This has a rich history. We'll delve into that in later sessions. Suffice to say, it's a friendlier version of an asynchronous polyadic reflective higher order pi calculus. Each of those words has,
oh, it's that simple, huh?
That's as concise as I can make it, but each of those words can be unpacked a great deal, yeah. Roscala is a virtual machine effort that derives from Rosette. So let me speak about Rosette first. Rosette was a virtual machine that Greg and some others wrote back in the 90s. It's C++. It uses mutable data structures. It uses some tricks to optimize memory usage and avoid all kinds of problems that were inherent in the computers of the time. It has built-in garbage collection. It's a very specialized machine. It was deployed, has seen some action. Since then, lots of things have changed. We would like to be able to prove things about this machine, and so part of the project was to port that machine from C++ to Scala. So the Roscala effort is this porting effort, moving from C++ to Scala, changing the mutable stuff to purely functional stuff, trying to clean it all up, use type safety wherever possible, that sort of thing. Communications layer, that's of course necessary. We have a node, it has to talk to the other nodes. Then there's the consensus algorithm. We call it Casper, but Casper isn't specific enough. There's some history. Vitalik, who's the leader of the Ethereum project, has his own version of Casper. Vlad Zamfir, who also works for Ethereum but is on Rchain's board, is developing a family of Caspar algorithms. We're choosing one for use in Rchain from that family. And then contracts, there are 3 different levels of contracts in the system that we're designing. The lowest level that doesn't use consensus at all, in fact, is the level at which consensus is built. It's called the system contract. Then there are contracts that run on the blockchain but play special roles and interact with system contracts. Those are called blessed contracts. They don't require funds to run because it's just part of the system. Every node has to run them. And then there are the user contracts that are the blockchain ones that everyone's thinking about. So to go over the state, storage. This effort is led by Henry, and Yaroslav is working on that as well. What they're doing at the moment... Was it released
recently, right?
Yes. Yes, there's the RSpace project released a library. It's functional. You can go out and use it. It is a key value store. Under each key, there are a set of values that are stored there. The values are of 2 different kinds. One is data, and one is what we call a continuation. It's what to do with data once it shows up. So you can store either one first, and then when the other kind comes in, they hook up together and then continue the computation. So all of that is built. Go ahead.
And what's the, can you describe the query language that you use to interact with RSpace?
Sure. The query language itself is Rchain. When you say, I want to fetch something from this channel, say the channel is X, I say for Y from X, and then I write some program in the interior of that body. The Y part binds to one of the pieces of data that is waiting there at that key, and then gets substituted in to the body of that continuation. So, yes? Here's a mic.
I just wanted to amplify what you're saying is that Y can be a pattern.
Yes.
Which means it really is a kind of query language because you're only pulling out data that matches a certain shape.
Yeah, so Y itself is a piece of Rchain code, and it pulls out any data in the database whose structure matches that piece of Rchain code. So the Rchain code has free variables in it. If I had a whiteboard, I'd draw it for you, but I'm not sure everyone's interested in that particular detail. But suffice to say, you write Rchain code, you can then grab only those pieces of data from the database that match that structure. So if you put a list in there and said XYZ, it would only pull out data that looked like a list with 3 elements, and it would bind X to the first one and Y to the second and Z to the third. But I could just as easily say for underscore from XP, and then it would bind X to the variable that was being listened on and P to the body of that comprehension. So it's a very, very powerful language for querying the database.
Yeah, it's part of the reason we started with it, part of the reason that it was one of the things that we tried hard at the very beginning to release separately is because, in my opinion, RSpace as a database engine is one of the coolest inventions in databases in a long time, right? Like, it's the beating heart of Rchain, but it's also, like, on its own, a really cool database engine. So if you're a Scala programmer in the room, I highly recommend you download it. Jake Gilberg just wrote an Xstream. Is that what it is? Yeah, an Xstream wrapper for it, so you can use that to interact with RSpace. Play with it. It's pretty sweet. It's a very sweet piece of kit.
It's also completely parametric. So if you don't like the Rchain language, you can provide your own matcher and your own language's continuations and run it that way. This is a fantastic design that Henry came up with. We are using it both for the Rchain continuations as well as the compiled Rosette continuations. So depending on, and the Scala continuations for the native processes. So when you pull out the continuation, you look at the tag and say, is this the kind of continuation I understand? If not, you hand it off to a dispatcher and it sends it over to the engine that does understand it. So it's completely generic. Highly encourage you to use this. The state right now of the project is that there is a release, but it doesn't yet support the history and rollback that we need for working with the consensus algorithm. So those are the two things that are under development at the moment on the storage layer.
Right, so that'll involve being able to snapshot over time, and then as the consensus algorithm tells you got it wrong, you can go back in time, get the data from there, and then replay transactions going forward, right?
Right. So executing one way, then you receive evidence that you should have gone another way, and then you receive more evidence that you should have gone this way, so you move back and pick up where you left off. Yeah.
Cool. All right, what's next on our list?
Rchain. So the Rchain, the Rosette machine was taking a long time to get translated. We were worried about the deadlines. We wanted to have something else in our back pocket. Then we found out that there were some good language-based reasons for keeping track of the original source code as well as the compiled source code. So we started an interpreter project. And when we say Rchain, this is mostly the interpreter project. The interpreter exists right now. You can go download it, execute real contracts. They're not blockchain contracts yet, but it is a working language.
This is in the SDK release, right?
It's in the latest release, anyway. The SDK release only had the compiler in it. Meta, which... The January 31st.
The January 31st release had the compiler and the C++ Rosette VM for execution. Yeah. The most recent release has the interpreter.
Let's see. Right, so you can execute contracts. It is a Turing-complete language at the moment. We're adding language features to make it more friendly. The most recent commit that hasn't been pushed to master yet, but is there on the dev branch, allows invoking methods on certain processes. So lists now have a method where you can pull out their nth element. We were bending over backwards to implement lists differently until we had that method in there. We're also working on the foreign function interface so that you can load up a jar and then invoke the methods and constructors on the classes and objects from that jar. We're going to be using that principally for the foreign function, for the cryptography that's necessary. Because of export restrictions in the US, which still exist, they're much less than they were in the 90s, but you can't ship to nations in the axis of evil. We have to distribute the crypto library separately as a jar and verify that when you're downloading that, you're not in one of those countries. But that's where the language is at the moment.
Cool. And so talk about how we're going to integrate the VM with the interpreter.
Right, the VM is still necessary and important. Turns out that it's very simple to look at a piece of Rchain code and figure out what parts of it need to be compiled that are program and what parts are data. So at any point we can compile a term, store it for fast execution, and then if the data itself needs to be evaluated, there's a star operator that turns the name of a process into a running process. Then we can invoke the compiler at that time as well, do just-in-time compilation. So both parts are integral to the speed and performance of this.
And how's the Roscala VM coming?
Roscala is coming along. There have been a lot of challenges in a system, well, in C++, you maintain references or pointers to objects. That's a number that's the location in memory of an object. And if you know the location, then you can go in and poke it and change it. That's a small piece of information that you need to know in order to make a change. In a purely functional system, you have to carry around a state object that represents the entire state of the system, pass it between methods, and then look at what the current value is, create a new state object that looks the same except has one part of it changed, then pass that back along the return channels. In order to do that, you need to be able to find for any number in the, any address, any location in the C++ code, you need to be able to find a path through all of the fields and methods of the state object that you're passing around. And this is a very complicated problem, and Tim and Alex that have been working on this have made enormous progress toward achieving that goal. It does have a lot of roadblocks, and so progress hasn't been as fast as we first estimated, but they are still on track to finish by the time we release. The current things that they're working on, finishing the transition function, which says when I get an opcode in, how do I update the state, but also working on primitives. The way Rosette works is that it has about 30 opcodes, but it has 350 primitives. So there's a large library of these snippets of code that then get loaded in by an opcode and invoked. The opcodes are largely done. I think there are 2 or 3 of the most complicated ones left. We did all the simple ones first. But we're on track to finish, and we also know which of the primitives are going to be necessary for supporting running code on the blockchain as opposed to those that were necessary for the other applications that it had in the past, that the VM had in the past.
And we've also been updating the C++ Rosette, right?
Yes. So in order to keep this code maintainable and also to better understand the code, we are maintaining the Rosette VM. We've encountered various places where there are bugs in the VM that its deployment didn't test. So we're fixing the bugs. We're factoring out the RBL compiler. So RBL is what's called Rosette base language. It's a Lisp-like language, and all of the source code that goes into setting up the environment for a working virtual machine is written in this Lisp-like language. So part of the Rosette virtual machine is a compiler from RBL to bytecode. The bytecode is a pretty faithful representation of the Lisp-like language. It's a really interesting design. If you're into virtual machines, I encourage you to go look at that design. But Roscala is implementing the part that doesn't contain the compiler. So we're trying to factor the two out, be able to use the RBL compiler when necessary to build up an initial state for the virtual machine, and then only invoke it at those times when the virtual machine needs to recompile some RBL. We're going to expose that C++ RBL compiler as a primitive invoked through the Scala FFI so that Roscala can use it, but that won't be exposed directly to any of the system contracts written in Rchain.
Anything else you want to mention on the VM side?
Let's see. I think that's it for now.
Yeah, okay. I think one of the things that's particularly cool is we're going to end up with a virtual machine that was written back in the 90s. It's going to be end of virtual machine that's written today in Scala. They'll be composed in such a way that we can use them to test each other, right? To verify that that everything's still correct, right? So we've got this corpus of code from back in the day, and it expressed a bunch of the core ideas that are inherent to Rchain, and it's going to keep us faithful and honest to be able to use that to test our current code. It'll help us ensure that what we produce from Mercury is actually correct. Right? So that's a fun idea. Okay, so communications.
Comms layer. We had Chris working on that. He produced some initial code. Chris decided to leave the project, and we were fortunate enough to hire Pavel. Pavel has been leading the effort to refactor it, continue the work on the project. There's existing code now. The things that we're working on are monitoring code. So you want to see how your processes are doing, what the performance is, what the bandwidth it's using is, make sure everything's working properly.
So I think we're using the KMon library. It comes with Scala to do monitoring. So for our testing, we'll be encouraging people to use Prometheus, but KMon integrates with a number of different production monitoring systems. So our goal is that by the time that we release, obviously we're going to have some of this in the testnet. By the time that we release Mercury in Q4, we would like the Rchain node to be the easiest and most professionally manageable piece of software in the blockchain environment, right? So you should be able to drop it into a production environment, integrate it with your existing production management tools, and just run it as if it was any other server in your stack.
Great. The original design had UDP, but we're moving over to TCP and using Google RPC, gRPC. We're sticking with Kademlia, but right now it is, for the moment, we're sticking with Kademlia. Right now it's tightly integrated. We want to break it out into its, make it somewhat more modular. Let's see. We'll be using TLS for the public key infrastructure and identifying a node with its TLS public key.
All right, so maybe let's talk about contracts and then we can talk about consensus last.
Right, so there are various kinds of contracts. Michael Birch has been doing most of the actual authoring of Rchain code on our team. We have system contracts, blessed contracts, and user contracts. System contracts, we thought were going to play a much larger role. It turns out that they're not strictly necessary, though they are desirable. So for the moment, the contract that implements the consensus algorithm is going to be written in Scala. We intend, as the language support gets larger, as we build in more features to the language, to port that Scala code doing the consensus to Rchain. But in order to meet the deadline, this is the fastest and most sure way of getting the thing deployed. The blessed contracts will include Rev, which is how everybody's going to pay for running stuff on the system. It will include the bonding, unbonding, and distribution of funds necessary for the Casper algorithm to work, the consensus algorithm. And finally, the registry. So there's a whole system of public names that we're going to make available for people to run contracts at. One kind will be based on the hash of the contract. That's pretty straightforward. In order to register a name in the row:hash: namespace, you just have to present a pre-image of the hash you're claiming, and that pre-image is just the contract you want to run. We're also allowing a pub key namespace where you present a signed challenge. So it issues a challenge to you, you sign it, give it back, it says, sure enough, your public key validates this challenge, signed challenge I gave you. And finally, there's an IANA namespace where you prove ownership of a domain. And so by proving ownership of a domain, you can run a contract there, but then it also gives you the opportunity, if the domain changes hands, to deploy a new contract running at that same domain, now in someone else's possession. All the old contracts that run using that old name have the option then of looking up the current owner of the domain each time, or deciding that they're going to stick with the original deployment and doing that. So both client and server have the opportunity to choose how they're going to interact with each other.
This is one of the coolest, least mentioned features of Rchain that we've come up with, because what this enables is for every node to be an entry point to a decentralized version of the web. right? You can take the exact same web applications that you've been running in your data center behind a firewall, rewrite them for the blockchain, deploy them, and then every single node that's participating in that namespace can serve queries off of those names, right? And that's something that no other blockchain is even contemplating being able to do. It gets me excited.
Yeah, there's a lot of fun stuff. It's, you know, I'm down here in the details, but it's really fun to pull back and look at, wow, what is this system we are creating? It's going to change the world. The reason for the registry from a technical point of view is that if you have a name, you can both send on it and listen on it. Therefore, if somebody has given you a name to communicate with their contract without a registry, or at least a way of restricting the power of that name, anyone you give that name to can then begin listening for messages intended for your contract and begin to intercept them. So we have a system both of registering names as well as restricting the power of names to send and receive. So you can get a read-only version or a write-only version or a neither version. And the neither version ends up being useful for doing authentication. If you have a copy of this thing, it lets you prove that you've got a copy of it, but doesn't let you do anything else with it. So that's where we are with the contracts, the registries. Lots of code being written. We encourage you to get involved with that. Give us feedback on what you found difficult so we can tweak the language to make that easier. I'll say something about the language itself. If you've ever done asynchronous programming, so on the web, for instance, it would be AJAX with the XML HTTP request. You know that you send off a request, and then you do the callback function that is waiting to receive what comes back. That is absolutely everything in Rchain. Every production you do is either a send or a receive, a callback. And so if you want to fire off some computation elsewhere and then get the result, you have to send along a return channel that says, when you finish, send me the result on this channel where I'm listening. So everybody's setting up these servers that are making requests to each other, and they have to pass around the IP address, more or less, of the server they're listening on for where to send the result to. So absolutely everything in Rchain is this asynchronous style. And so it can be odd for someone who is coming from a synchronous programming background to step into this. But if you think of it all in terms of AJAX and doing everything that way, then you ought to be okay.
Yeah, and Kyle Butt is giving, where's Kyle?
Right there.
Oh, there he is. He's giving a talk later on what Rchain is simple but not easy, right? So if you, which is a compliment, actually. So if you want to know more about the details of Rchain and you want to understand exactly how it works internally, go see Kyle's talk this morning.
Great.
Okay, so consensus. So we were up early this morning to talk about consensus.
Yeah, consensus is hard. The proof of stake algorithms that people have haven't been proven. No one has deployed a proof of stake algorithm that has been proven secure. No one, Ethereum has a test net with Vitalik's version of Casper, but it hasn't gone to production yet. There's still very fundamental issues that we are trying to work out. But we have a broad view of what it ought to be, and we have confidence that we're going to be able to achieve it. So this morning, we had 6 or 7 questions that we needed answered. We got one of them answered. But we still have...
That's a pretty good meeting, actually.
Yeah. We still have several months to get this stuff done before we need to deploy a test net. We're on track.
Good. All right. Okay, so that's sort of the status of the dev stuff. Let me take the temperature of the room. Do you want to ask questions about that, or do you want us to go through all the rest of the topics and then ask questions at the end? So hands for questions right now. None. Okay, great. All right. So on the infrastructure side, one of the burning one of the obviously the economically important topics is how exactly rocks are going to get swapped to revs. I'm giving a talk later today, this afternoon, I think, where we'll talk specifically about the mechanics of how we're going to do that and sort of give everybody a sense for what we think they're going to have to do to successfully transition from the rock market into the rev market when we launch the blockchain. Suffice it to say, I think that we can do this in a way that's relatively straightforward for rock holders and safe for the co-op. The main issues related to the swap are whether or not the co-op takes complete responsibility for making the swap correct, or whether we use the community to sort of crowdsource correctness, right? And so in the spirit of decentralization and radical transparency, I'm advocating for using the community to verify the correctness of the swap at Genesis, and later on I'll go through the exact procedure that we're proposing for how to do that. But the idea is that that will then allow the co-op to say, you know, we had the community go out and verify all the data, and that data went into the Genesis block, and that's you know, as good as we can do. That'll be good for, you know, limiting co-op liability associated with any errors. In order to do that, you know, obviously there's going to be a large ceremony in Q4 when we publish the Genesis block. So all of you who want to be validators, right, you'll be wanting to pay attention. We're going to start asking for people to register interest to be validators sometime later this summer. Probably contemporaneously with the launch of the testnet, we'll start asking for people to sign up for mainnet validation. We're also going to, at some point this spring, begin to sort of give people information about when the rock rev swap will happen, right? So what we're likely to do is reveal a few bits of information every few weeks, right? So the specific date is still foggy because we have to have the software ready, and then obviously software projects have variances exactly when they deliver, and we haven't scheduled the specific Genesis ceremony. So we know it'll be at a certain, it's relevant like exactly what the Ethereum block height is when the swap occurs, right? So what we'll do is, starting this spring, we're going to begin to reveal bits of the Ethereum block height that will tell you when you can expect Genesis to be relative to the Ethereum blockchain. That'll give you more and more information as we get closer and closer. It'll narrow the window of when the Genesis block will actually get published. So if you're not that concerned, you can do what needs to be done with your rocks. You know, this summer you'll be done. Then you just wait for Genesis to happen, and it's no big deal. If you want to, you know, you're trying to high-speed trade the market or do something funky, then you'll want to keep track of exactly when it's expected to be. Right? One of the other issues related to Genesis is signing the software and signing the initial blocks. So this spring, PyroFX will start issuing keys. If you're going to run nodes, you should get our keys early, validate them. You can email us, you can call us, ask us to, you know, check the signatures, come up to us at conferences to do signature key exchange. Those keys will be really important for validating that you've got the actual correct software, and when we go to launch, that you got the correct Genesis block that we'll all validate together during the launch ceremony. So we have to bootstrap the thing somehow, and it's got to be key exchange and meet space is the best way to do that, right? So for the moment, communicating with Mike and I will be the way that you can do your meet space key exchange, not at this conference, but in the future, once we've begun to publish that stuff, you'll be able to do that. Talked about, I guess, obviously the biggest piece of data that goes into Genesis other than the rev balances, which we all care a lot about, obviously, is the list of initial validators. I think part of the vision for the blockchain as a whole, and I'm sure Greg will speak more to this over the course of the week. If you have questions about this, you should ask him, but I think part of the vision for the network is to have a broad range of validators, from, you know, large players who have invested a lot in their infrastructure to small guys who haven't who want to participate but don't necessarily have the same kind of capital to outlay. We want validators of all different kinds. So we would like to hear from you if you're interested in being a validator, if you know people that are interested in being a validator, come find us, talk to us, tell us what your thoughts are so that we can understand how you view the economics. There are still parameters that we have to choose in consensus and in the namespace architecture that will allow us to build it in different ways depending upon what people are looking for. Obviously, for us, one of the big things is to make sure that the network performs at the level that we want, right? We're all hoping for a blockchain that can do tens to hundreds of thousands of transactions a second, have low latency, high throughput, and all that great stuff because we want to write giant applications on it that are going to take over the world, right? So in order to do that, we need a combination of specialized hardware and lots of decentralization, and they have to play nicely on the same network, right? So one of the big things that we want to know is who are the people who are going to form that initial validator set, and what are they interested in contributing? So that's an important piece of the infrastructure for actually launching. You have any thoughts on that? Any of that? No? Okay. One of the questions that we get a lot is how do I learn about this stuff? Obviously, there's a fair amount of documentation. The primary place to go to learn about Rchain, to learn about the Rchain, the blockchain architecture, that kind of stuff is developer.rchain.coop. That's our developer team website. We publish all of our specs, all of our releases, all the documentation that we've got that is published there so that you can get access to it. There are a number of people that I know that came this week specifically to find out more so that they could develop educational materials. We are not nearly as far along in that regard as we could be. So this is an area where if you're interested in this stuff, you could really help us out by pestering us to talk to you about how to help build educational materials. Part of one of the parts of the vision that Greg has that I particularly love is the idea that what we would like to do sometime starting the end of this year is capture teenagers and kids building games and apps and chat things that were relevant to the next generation, so that when the next generation learns to program, they're learning to program Rchain, and they're learning to do it on the blockchain, right? Because that's the future of computing in our vision, and it's the way that we're going to grow this community most effectively over the course of the next 10, 20 years. That's all possible in our opinion. Rchain it's simple, right? It's not easy, but it's simple to learn. And I think Greg's experience teaching teenagers to program in asynchronous message passing style has been that it's very intuitive in a lot of ways that sequential von Neumann machines just aren't, right? And so this is part of the vision for the educational programs that we would like to build. But this is an area where the community can really make a particularly large contribution. So the dev team would love to hear from you if you are interested in helping us with that and contributing to that. Please find us and pester us to give you what you need so that we can build these programs together. Okay.
Just one comment on documentation. We have various specs being written at the moment. We've hired a guy named Derek who's working with the K framework system in order to specify the operational semantics. The output of that project will be the generated PDF from the K framework program describing exactly what all the transitions of the language are, so anyone can build a conforming implementation. We have Tim and Keith working on the VM spec, so exactly how the Roscala VM is going to work. Pavel's working on spec around the communications layer. Henry is working on spec for the storage layer, and sometime within the next week or so we're going to be updating the architecture document that's now quite out of date, but the original one we posted last time.
Last year. Yeah. Cool. All right. So I think that covers pretty much everything that we wanted to cover in terms of explaining where the project was. At a high level, I'm really excited about where we are. It's April. We've got something like 7 or 8 months to go, and it's starting to look to me like we're going to get there. That's always a nice turning point in a software project where you develop confidence in your delivery date. So that's, if you take one thing away, that's what I think I would take away at this point.
Just on that, to think 1 year ago, they were doing the AMP for ROC exchange. Nothing had been done yet, and yet we're here within a year. So I think 8 months sounds like a short amount of time, but our team is growing exponentially, and there's still plenty of time to get done what needs to get done.
Yeah, for sure. So I think what we'll do at this point is take questions. So hopefully you guys have questions. It looks like we did not use the entire hour and a half, so if you have limited questions, we can give Vlad a chance to start early. I know when we told him he only got an hour, he was like, oh, that's not very much time. Ed, make sure it's on. Green means go.
Hello, there
you go.
Hey Nash, Mike, great update. Can you tell us a bit more about foreign function interfaces and how a user-level smart contract might or might not use foreign function interfaces? And then can you talk a bit about oracles and how you see those integrating?
I can talk to that.
Okay.
All right. So user-level code on the blockchain will not use a foreign function interface. It is not wise to expose the ability to load arbitrary jars off the node to arbitrary code running on the blockchain. System contracts will use the foreign function interface. So a system contract will, in the current design, will go and load up the crypto jar and will expose the Java crypto objects and constructors to Scala code as channels that you can send to. Basically, if you've got a method with n arguments and a return value, you turn that into a channel expecting n+1 arguments, where the last one is the return channel. So you send all of that information and it returns the value along the return channel. In programmer parlance, that's very similar to a continuation passing transformation. So that'll be automated. Any Java jar can be, all of its constructors and methods can be exposed in just that way. The only complication with that is that the only thing that can cross the boundary is data. You can't have a Java object stored in the tuple space. So there may be some layer of middleware that needs to be written to efficiently expose a jar that has more functionality requiring Java objects to be passed around that aren't just data. But by and large, it can be done automatically. Oracles are what we are calling code that is running off of the blockchain but will inject data back into the blockchain. So for example, if your contract wanted to fetch a web page, if you have 1,000 validators running, you don't want 1,000 hits all at once to hit the web page. So running an oracle involves a leader election usually to pick one validator to go do that thing. And because it's off the blockchain, there can be no consensus about what happened. You can't independently validate the page that got sent back. I mean, if you hit a web page with a counter in it, everyone is necessarily going to be different. So an oracle is just this thing that reveals data to you and you accept it by fiat. So leader election to pick one validator to go interact with the oracle, report what it received, and then that will be handed back. The way oracles get triggered is probably going to evolve. Right now, you can do it as simply as having some process watch the state of the blockchain, and we'll talk later about namespaces, but there's a bottom namespace where there are no validators in it. You can still send to names in that bottom namespace, but they just get the data on them and the continuations listening there just get thrown away. But you can use that namespace for debugging. You can use it within system contracts for accessing special built-in processes. You can use them in blockchain contracts for communicating with oracles. So you can send information there. The oracles are watching the bottom namespace. they see that a message was sent there, they do something, and then act as a client to deploy new code into the blockchain in response to that message. So that's how oracles are currently slated to work.
I'm not so sure that I agree with Mike that you shouldn't hit a web page thousands of times, but there's there's scaling issues there, and so let's say if we wanted to do oracles where all the validators measured something, then the guarantee of what's being measured is that eventually they have to observe the same value, right? And that's not generally true about the web. So this is only like useful in certain circumstances.
Sure, and anybody who wants to can certainly set up a system where they will always return the same thing in response to the same query, maybe sign it, and the public key can be stored on the blockchain. In that circumstance, you can have all of the validators hit the web page, all get the same result, cryptographically verify it. It's just for systems that don't know anything about the blockchain, there is a way of communicating with them in order to do that. Greg?
I'm sure there are a lot of dApp developers here and people who are envisioning using Rchain that either have existing assets or are in the process of building assets or contemplating building assets that are not written in Rolang, that might be written, say, for example, in some JVM language. So when we say there are no user-level foreign function calls, can dApp developers write system contracts so they can get those assets into their overall application architecture?
We are designing the system to be object capabilities secure. So in as much as they write system contracts that have no free variables, that only use the channels that have been passed into the system contract, we can support that sort of thing. I'm not sure that we will be able to support it by Mercury.
Understood. Okay.
Yeah.
More questions? Yeah,
Come on up.
there's a mic here, there's a mic back there. Step on up.
Hi, I'm Kayvon.
Hey, Kayvon.
So today I can go and write a hello world or something simple, and use the interpreter, use the Rolang, and build it and see some results. Can you talk a little bit about the deployment model? What would I have to do if I want to write something a little bit more complicated and I want to be able to execute it from anywhere? For instance, I can write a Scala, I can put it in a Docker, and I can put it in a different machine and execute it. Do I have similar capabilities with Rolang?
Yeah, so we definitely ship Docker images, and you should be able to use them to build Rolang applications and deploy them anywhere that Docker runs as standalone apps. And part of the vision for Rolang is that it won't just be the programming language for blockchain smart contracts, but that it will be a useful general purpose programming language that you would write middleware and business logic and all kinds of other things in. So Docker is definitely one of the ways that you can deploy it. We also have native packages for Debian and for Fedora, so you can download apps and RPMs and install those and run them in whatever environment you're using. To deploy on the blockchain, the network has to be running, and the node has to support being able to deploy contracts. That doesn't exist yet. It's coming it's coming soon in the node, right? So it will be possible at the launch of testnet later this summer to be able to deploy Rolang as a smart contract on the blockchain. And then you can have your smart contract running on the blockchain. It's fed by Rev essentially, and you'll be able to have your Docker container running your middleware portion of your dApp that's also written in Rolang, deployed in whatever cloud or data center or whatever infrastructure you've got, right? So that's sort of how we envision it would be the most straightforward for people to do deployments. Obviously, you can write your middleware in anything you want and still be able to talk to your smart contract as long as you're running about a node. Nodes, you can run the node in either validator mode, in which case you're going to have to stake the net. You'll have to put up a stake to join a region, perform validation functions, participate in Casper, and do it correctly without equivocating, right? Or you'll be able to deploy the node in a sort of read-only mode where you track what's going on in the regions and namespaces you care about, but you don't participate in Casper and you don't have to stake. And a lot of folks that are writing dApps will want to run read-only nodes that do this because that'll help capture the state of their dApp so that they can interact with it, and it'll provide the API endpoints that'll allow you to sort of inject transactions into the network in a scalable way. Did that answer your question? All right, thumbs up, okay. He was next. Turn it on. Green means go.
Yeah, so my name is Renke Hendrikse from the Netherlands, and I would like to ask you, how are you planning to upgrade the code and to add features after Genesis?
Ooh, that's a good question. Mike, do you want to answer that one? To upgrade. Upgrade after Genesis. I mean, this is a really good question, right? Because it's actually incredibly hard. And this was an issue that came up in a lot of detail at the governance forum in February, right? So the short answer is we're not sure yet. Right? The long answer is that this has to involve both a technological solution and a governance solution on the cooperative side, right? So as we get closer to Mercury, we have to have maturity on the technical side, which means that we have to get our releases out there. They have to be signed by well-known public keys. They have to contain, initially they'll contain Genesis blocks, but down the road, what the release will contain is snapshots of the regions so that you can tell. Upgrading, a big part of upgrading is correctly synchronizing to the main chain, right? And so that's a big part of what the software release process has to handle. We are beginning to build out that infrastructure, which is why I mentioned later this year you should find us in MeetSpace and do the MeetSpace public key exchange thing so that you know when we publish an RPM or a deb package or a Docker image, you can check its signature and make sure that it came from us. But also, that's just on the technology side, right? The co-op also has to come up with a governance model that directs how features get chosen, how they get implemented, when an implementation is determined to be correct for the feature that was desired by the cooperative. And this process is just beginning, right? Meta and Kelly are good people to ask about the what we're calling the RIP process, I think. The Rchain, what's the
RCMP?
Improvement process. Yeah, Rchain improvement process, or RIP. And the idea is that there's a cooperative model to choosing improvements to the protocol, and as well as sort of directing how the dev team will implement those features. But I'd be lying if I said it was simple or if we were done with any of that, right? It's all very much being developed and it's very much in flight. So
it has been our plan that Venus will contain so many new features at the language level that the Mercury deployment would be its own small namespace as part of the Venus deployment, and people would be incentivized to move away from the Mercury network into the Venus network because of all of the better support. For example, behavioral types, better static analysis, purely functional sublanguage is under consideration. Lots of different things are under consideration for inclusion in Venus that we simply don't have time to get to in Mercury. So Mercury is really a proof of concept network that we intend to learn from and then deploy the Venus network, which will be better in every way. So if you've got code running on Mercury, we intend to develop tools that allow porting it easily to the Venus network, but we're not guaranteeing compatibility with the Mercury network in Venus.
This one's definitely on.
Hi, I'm Jim.
Hi, Jim.
I'm really new to Rchain.
Great.
And fairly new to blockchain, but one of the things that really attracts me is scalability, and that you guys are heavily focused there. The one issue that I see is that for this calendar year, as an example, both inside the enterprise, needing to deploy blockchain that's on kind of like a fully released blockchain, and developing apps and smart contracts for that. Is there thoughts or sessions that'll talk about how to maybe bridge the gap so that you can sort of maximize the amount of usage of anything that you develop this calendar year, but be able to transition it to Rchain kind of as the tools become the tools and the base infrastructure get built out? And I guess
Greg says yes.
Yeah.
Just to make sure I've understood your question. I mean, are you saying developing on an existing blockchain like Ethereum and then leveraging that development effort over onto Rchain?
Right now, I'm specifically thinking like Sawtooth. So, as an example, on the Hyperledger project.
I see. Okay.
And like as an example, they have a module that allows you to run Ethereum, a subset of Ethereum smart contracts on Sawtooth, and that's one way to kind of bridge over folks from the Ethereum blockchain to Sawtooth. Is there kind of a similar type model that could be used?
So we are absolutely targeting that, but again, the sequencing is a little different. It's not like we'll provide that now, and then you can just hop over. Pyrofex is developing a suite of tools called CryptFX, which is all about developer tools for Rchain. And included in that tool set, if I've understood correctly, is exactly the kind of thing that you're talking about, where you could potentially compile a Solidity contract over onto Rchain. Now again, Solidity has no features that allow for concurrency, so it'll be just as slow
Exactly. Yeah.
over here, but now your contracts run over here. So to get the advantage of the speed and scaling, you're still going to have to port to Rchain. But
Right.
you can kind of move your
at your own pace, more or less.
At your own pace,
At your
yeah.
own pace. And
Yeah,
then the
that's the
other
idea.
piece is really, I always think of interoperability. Anything that can be make it easier to onboard, transactions from some other blockchain onto Rchain is going to be attractive to a larger set of people,
so
too.
a lot of the namespace work is to make it possible to do exactly that kind of thing. Yes.
Beautiful. Thank you.
Yeah, in particular, one of the, I suppose you could call them namespaces, but rho:/pubkey:/secp256:key, that's where you can reuse your Ethereum keys on the Rchain blockchain.
How are you dealing with the persistence of smart contracts? Like, is there a rent mechanism, or is it just a one-time cost?
Ooh, good question.
There is a rent mechanism. The details are not fully worked out yet. At the moment, we're considering two kinds of cost for deploying code. On Rchain, you don't just deploy contracts. You can deploy messages as well for sending to contracts, and even partial continuations of contracts will end up living on the chain. But there will, instead of gas, we're using a term from 19th century physics called phlogiston, which was the idea of this fluid-like thing that carried heat energy around. Phlogiston will be split up into various components. I'm not sure what all of them are yet, but we'll at least have one for storage and one for computation. And so when you deploy code, you will pay storage phlogiston, which will decrement over time, and to compute, if you are invoking a contract, that invocation will carry phlogiston. If you are consuming a data feed, that consumption will carry phlogiston.
So if the sort of rent allotted expires, there will be some garbage collection of sorts where the contract
Yes.
falls off the chain.
Yes.
Yeah, it'll remember, it's sort of neat. It'll sort of remember a shadow of your smart contract, so it'll hash your smart contract and then remember that. And so you can come back later and supply additional RENs. If you have the original smart contract, you can supply the smart contract too, and it'll sort of get reinstated. But we won't have to store all the contract details, right? So it won't explode.
That's our current plan. Joe is arguing against it. It's still up in the air exactly how that's going to work.
Just take the mic, Greg.
No, so I just want to speak to this because there's a two-level architecture that we're currently contemplating that puts us in compliance with the new laws in Europe that have to do with ownership of data. So at the platform level, there's this rent mechanism which allows data to be essentially rolled off, ghosted or shadowed, as Mike was talking about. And then at the application level, to be in compliance, the application would have to encrypt user-level data and then prove that it can forget the key. And so now the data is effectively disappeared from the... So does this make sense?
Hello. All right, much better.
What's your name?
My name is Forrest. Hello.
Hi, Forrest.
Hi. How you doing?
Really well.
Cool. So I'm an Ethereum dev. Recently started diving into Rchain, so forgive me if this is clearly stated in the docs and I haven't seen it yet. Still working through. But what is the extent of historical introspection that is planned for being available inside of a user smart contract in terms of knowledge about historical state, be it block hashes, value of storage at historical points, so on and so forth?
We don't have anything built into the language at the moment for providing that. That said, it is very easy to run a separate thing that is watching the blockchain and is injecting that information as a data feed that can then be consumed.
Okay, so more like an Oracle situation.
Yes.
All right. Thank you.
Yeah, and part of the reason for that is that in proof of stake networks, you have to checkpoint, right? You have to have a snapshot at some point in time that sort of says this is what you can trust, because over time the validator keys, have an incentive to sort of fork off and do crazy things, and so whenever we talk about how to do that, right, it's also a convenient way to sort of forget a lot of data that we otherwise would have had to store, which is a nice parameter for a large-scale system to have.
Thank you very much.
Lads, ready? Okay. We can take more questions. We'll just,
I'll try to make it quick.
It's
hi,
all right.
My name is Mel.
It's all extra time for Vlad, right? So if he doesn't get any, it's fine.
Great. We're actually I'm very excited actually about Rchain. I've been working on the Ethereum for quite a while and been following Dalek for quite a while, and we're really excited about some of the things that blockchain is introducing to us. And one of the things that we really like is the zero knowledge proof. Maybe this is not the session to ask this question, but I just want to throw it out there. Is how Rchain is going to actually tackle that if the zero knowledge proof, if you guys are actually have that in.
So it depends on what you're proving, right? There are various things that you can do from within the language that actually don't involve cryptography. So one good example is our notion of a coin purse. The Rchain system is very much like Java in the sense that you maintain references to things, but these are unforgeable. That is, if I give you an integer, there's no way in Java to turn that into the object pointed to at that location in memory. So the references are unforgeable. If you don't have a reference to that object, there's no way to get it for the most part. There are some ambiently available ones, but for the most part, you can't get these. So there's a difference between a coin purse, which is one of these things living behind an unforgeable name, and a wallet, which has a public component. So I'm just going to talk about the coin purse itself. These coin purses can hold different currencies. particular currency needs to verify that the other coin purse that it's pulling funds from is of the same currency. Because if you've got a coin purse with a coin minted from gold, you don't want to accept one minted from lead, right? So the way it does it is inside it has one of these unforgeable names. It doesn't want to reveal that unforgeable name. So it issues a challenge to the other purse, which has its own copy of the unforgeable name. They put those two, the unforgeable name and the challenge together, bundle it, and return that bundle. The bundle can't be taken apart, so there's no way of getting at the unforgeable name within that. But I can also take my challenge, bundle it with my own unforgeable name, and then compare those two. And if they match, then I'm sure that that other purse is of the same currency as mine, and I can withdraw the funds. And so in that sense, it's a zero-knowledge proof of containing the same currency. So there's that sort of pattern that is possible. But we're also going to expose the crypto libraries because they contain no authority to cause side effects in the outside world on well-known channels that you can interact with. And so if you want to implement your own zero-knowledge proof protocols, you have the crypto primitives with which to do it.
Yeah, so one of the funnier side effects of having the blockchain, right, is that a lot of protocols that used to require crypto now can run, at least to economic security, without any crypto at all, right? And the way that sort of fundamentally works is that if somebody tried to break the protocol, all the other validators would catch them. It's equivocation, and they get slashed, right? So nobody is going to do that. Everybody's going to follow the rules and execute faithfully what should be executed. So even though there's data on the blockchain that's public and everybody can see it, it doesn't help you any because you can't get anybody else to break the rules, right?
Thanks.
Yep. Any other questions? Yeah, fire away. Oh, he's already wearing the t-shirt. I love it.
Hi, my name is Bilal Mohammed, representing Intelligent Product Solutions. I just want you to talk a bit about the economics of using Rchain. So if I'm building all my applications using Amazon, right, and most of my use cases are storage and post-processing analysis, how can I integrate or even move over to Rchain?
Oh, that's a good question. So the blockchain itself, right, at the most fundamental level is it's not great for the situation where you only want to do a big job once, right? And so when we deploy in AWS or cloud environments, or when we build out data centers, a lot of times we're trying to minimize replication, get whatever reliability we want from the infrastructure with the minimum amount of like duplication of effort across the machines that we do, right? And data centers are still going to be better for that than the blockchain is, right? But what the blockchain does is it lets service providers financialize their offering of that kind of compute, that kind of infrastructure to people who are participating in building applications, right? So, it's part of our vision that's going into the CryptoFX project is this idea that most of the applications that get built for the blockchain are going to be hybrids. They'll have a piece that runs on chain, and it'll have a piece that runs off chain, and that's just how ultimately, the new version of the web is going to integrate blockchain, because there will still be a lot of stuff that has to happen off chain because it's too big, right? You're not going to want to replicate it 1,000 times, right? Like that giant data analysis pipeline that costs you $1,000 a day. You're not going to duplicate that 1,000 times and then pay the validators to run it over and over and over again, right? So you're going to want to have a way of like running that in the cloud or running it in your data center, but then financializing access to the results, right? Or financializing the inputs. And that's what the blockchain is going to be really effective for. So the economics that we're focusing on and the tools that we're building for developers are all oriented around how to build those hybrid applications in such a way that you can use both kinds of environments to run the kind of code that's appropriate for each one. Sure. Any other questions? Okay, so I have one, since I have you all here, we have just a few minutes. I want to ask you, well, I want to tell everybody about something that's not Rchain related. So one of the things that we've done, and we've worked a lot with the co-op to try to figure out ways to fund tools that will be used by the Rchain community to help build out applications and develop DApps and that sort of thing. And CryptEffects, for example, is one of them that Pyrofix is working on very closely. Number of months ago, right, there was a lot of activity in the token sale market, and it was possible to fund a lot of projects out of the community that way. These days, the regulatory environment has tightened very quickly. Those kinds of efforts look a little bit less practical right now. But under an SEC regulation called Regulation A+, companies like Pyrofix are allowed to make offerings of equity to the public on a limited basis in a way that would allow us to continue to fund our projects that aren't specifically part of the co-op's work, right? So we are currently doing what's called a Test the Waters campaign for a Regulation A+ IPO later this year. If you go to pyrofix.net/invest, you can read about our Test the Waters campaign, and there's a form you can fill out there if you're interested in potentially investing and buying some equity in our company that would be used to build tools such as CryptEffects and other blockchain DApps that would be deployed in the Rchain ecosystem and elsewhere in the blockchain space.
And just to be clear, this is not limited to accredited investors with $1 million net worth. This is open to the general public.
Right. Yeah. Yeah, that's the sweet thing about the Reg A+ stuff is it's a way of giving normal folks an opportunity to get early access to equity in companies like ours, and smaller businesses like ours gives us a way to fundraise and maintain regulatory compliance. You got another question?
So it works now. I actually wanted to ask, well, I think Pyrofix right now, they're doing a great job in in terms of development of the platform, but are you planning to fade out your importance after Genesis? Are you planning to keep involved, and if so, in what way?
To be honest, mostly what we're doing is focusing on getting to Genesis and getting through Venus. I think Greg hopes, and part of our relationship with the co-op is always intended to allow developers from our dev team to move over and become full-time co-op employees, right? So that will start happening later this year. Some of our developers will do that, some of them won't. My desire is that there will be other companies that are similar to ours that will come along, will also participate. One of the design elements inside of CryptEffects, which we haven't talked a lot about, is the notion of having compilers and virtual machines with different provenance. In order to do that, we actually need other companies to start up and run those. So I think in the long run, yeah, we'll be less critical in the Rchain ecosystem than we are today. But hopefully we'll always be involved and always be, successful.
Thank you.
Okay, with that, I think we're going to turn over what little extra time is left to Vlad. So you probably get like a 5-minute break before he starts up. Thanks, guys.